My name is Samir, and I'm part of a team of product managers here at Maplesoft. So our role is to speak to our users and help them understand our tools, technologies, and services. We then take your feedback and put that back into the product development process. So I am very keen to hear about what you think of Maple 2025. So it is my distinct pleasure to give everyone a sneak peek, to lift the veil and show you some of what's new in Maple 2025. Now, based upon what you see on screen, the interface, I'm probably giving away our biggest new feature, but more on that later. Now, in an event like this, I'll never be able to give everyone a comprehensive overview of every single new feature in Maple 2025. I'll give everyone an overview of some of the features that I find most interesting, but certainly all of the information will be available on our website in the coming days and weeks. Now, Maple 2025 will be launched soon. It'll be here before you know it. But let's get started. So it's always exciting to present a new release of Maple 2025. Throughout the year, I see bits and pieces of what's new in Maple. There are small features which have a quick gestation time. It might only be a few weeks from the initial conception to completion. And then there are bigger features which take longer to develop. It's only near the end of the development cycle that I get to see how everything comes together and what we have on offer. I'm happy to say that I'm pretty impressed by what we have in Maple 2025. There's something in here for everyone, whether you're a student learning math concepts, whether you're an educator, or whether you're a professional engineer. There's something in Maple 2025 for everyone. So on screen, I have an overview of some of the topics I want to cover. We'll look at the interface, we'll look at units, we'll talk about Maple's connectivity options, we'll look at the advancements we've made in visualization and math. I want to talk about AI as well and what that has in hold for Maple. That's very exciting. But let's get started and let's talk about the biggest new feature in Maple 2025, and that's a brand new interface. Now, Maple has a very rich interface. It's an interface that we've refined and finessed over the last 10 years. There are many parts of this interface that I'm very proud of, that are very useful. So, for example, there's a context panel here on the right-hand side. So if I open this up, if I click on some math, I see context-sensitive options. So if I click on a matrix, you can see the items in the context panel changing. If I click on a differential equation or a transfer function, the appropriate context-sensitive options change. There are palettes in Maple as well on the left-hand side. These include tools for inserting mathematical templates, matrices, common symbols. I really like the variables palette. This lists all of the variables that you've defined in your worksheet. So if I define a parameter, f, that's listed in the variables palette. If I define a function, again, that's listed in the context panel. So in a worksheet, you might have 10 parameters, you might have 100 functions that you've defined. They're all listed and summarized here. There's also tools like command completion as well. So if you type in the first few letters of a command and hit escape on your keyboard, a command completion menu pops up on screen. You can simply select completion, press tab, and the command is inserted. There's argument completion as well, which is something that we introduced very, very recently. So if I type in a plot command, open brackets, an argument completion menu pops up on screen. So I can pick a completion, hit a comma, and I get a range of plot options. This is really, really useful. So moving on, we have a new interface in Maple 2025, and this has been a long time coming. It's a ribbon-based interface. So if you're familiar with Office products, you're probably already familiar with the ribbon interface. So we've replaced the drop-down menus with ribbons and tabs. There are large, meaningful icons, which allow you to identify functionality quickly. Items are grouped together logically in groups on individual tabs and in tabs as well. Ribbons are contextual as well. So if I click on an image, you can see the contents of this ribbon changing. We have a new drawing tab, which allows you to annotate the image with line diagrams, text, and so on. If I left click on this plot, I see a new plotting ribbon, giving me options for interacting with this plot. There's also a new education tab. This is really useful for educators and students because this collects together educational resources which were previously scattered about in various parts of Maple. We've collected them all here. Now, the new ribbon interface, I think, looks a lot cleaner than the old drop-down menus. It's certainly allowed me to find a lot more functionality more quickly. I've discovered various options in Maple that I wasn't familiar with before. Now, any change in look and feel can be divisive, but I want to make everyone assured that we will continuously refine the ribbon interface, but we can only do that if we get your feedback. So let us know what you think of the ribbon interface once you get your hands on a copy of Maple 2025. And we'll certainly take your feedback into account when we're enhancing and finessing the ribbon interface. We've also made another fundamental change in Maple, and that's the equation editing experience. Now, traditionally in Maple, you'd have to use the right arrow key to navigate out of exponents when you're typing in some math. Let me zoom in here. So here, the cursor is in the exponents. Now, this is a very, very common input pattern. We actually have a library of thousands of Maple worksheets, and we trawled through them all, and we identified the most common input patterns for equations. And we wanted to make entry of those common input patterns easier than before. So now, if I type in something like this, if I just insert another arithmetic operator, like a plus, the cursor drops down to the baseline. It's the same with division as well. So traditionally, if I wanted the cursor to move to the baseline, I'd have to use the right arrow key. Now I can just type in any other arithmetic operator, and the cursor is automatically inserted on the baseline. This really makes equation editing far more intuitive, far more useful. Now, if you don't want the cursor to jump to the baseline, you can always use the arrow keys on your keyboard to navigate back to the baseline. We've also improved argument completion as well. That was something I showed you earlier. So if you're not aware of what argument completion is, let me just zoom back out so everyone can see the argument completion menu pop up on screen. So when you type in a function name and then a left brackets, in prior versions of Maple, I think this is something that we introduced last year, an argument completion menu pops up on screen, giving you a number of arguments or completions, stuff that you might type into the brackets. We've refined this experience so that more relevant items appear in the argument completion menu for many more functions. So here I've imported a few audio files. In prior versions of Maple, it would only give you one audio file in the argument completion menu. And now it gives you all the relevant completions. So now I can select the appropriate completion, press enter, and I get my plots. I've had a question through on the chat window about the equation editing experience. So when I type in something like 1 over f, if I type in an open brackets, the cursor stays on the baseline. Let me try that with something else. X, forward brackets. The entry of the left brackets does not make the editing cursor escape to the baseline. It stays in the baseline. So let's move on from the interface. There's lots more to talk about. Let's talk about units. So units are a growing part of the whole Maple experience. This was functionality that we introduced many releases ago, and since then we've been refining and integrating units more deeply into the entire Maple system. More functions understand units, and the whole process of using units to compute with is much more easy now than it was a number of releases ago. So this is an example. So here I have a couple of parameters. I have an equation that I want to solve numerically using fsolve. That's our numerical equation solver. The results pop out with units associated with them. If I want to rescale this to another unit, I can do that with the context panel. We've added more functions in Maple that understand and can process units. There are a number of new top-level commands for rounding quantities to integer multiples of a second argument. And this is particularly useful when you're rounding a quantity with units to another unit. So this is one example I like. So here I'm rounding 1.24 feet up to the nearest half an inch. That's really useful. The sort command now understands units as well. Here I'm giving sort a vector of quantities with units, and it's sorting them appropriately. The plot command now understands data with units as well. So here I have two vectors of data, one with units of meters, another with units of watts. The plot command can now be used to plot these two vectors. Now, a few releases ago, we made the int command compatible with units for numeric integration. And now we've done the same with fdiff. That's our numeric differentiator. So here I have an expression. I can now use the fdiff command to differentiate this expression with units. So this is a distance, I'm differentiating it with respect to time, and I'm evaluating the velocity at a time of 5 seconds. Since this is compatible with units, I could specify the time in minutes, press enter, and it gives me the appropriate result. And just because this is something I'm very familiar with, thermodynamics, here's an example involving thermophysical data. So the specific heat capacity is defined as the differential of enthalpy with respect to temperature at constant pressure. So here, I've used the thermophysical data package to extract an expression that gives me the enthalpy of water at a constant pressure of 1 atmosphere, but with the temperature left as a symbolic quantity. I can then use the fdiff command to differentiate the enthalpy with respect to temperature and extract the specific heat capacity at a temperature of 298 Kelvin. And that's the value I expect, and that compares very well with a built-in value. Let's move on. Connectivity. Let's talk about all things connectivity. So one of the hallmarks of Maple is that it's a very open package. You can import many different types of data. You can connect Maple to other tools in your tool chain. You can generate code. This is one example. Here I'm importing earthquake data from the US Geological Survey website. I think that's the URL there in that tooltip. If I change some of these parameters and click on Live Update, Maple talks to the US Geological Survey website and downloads the latest earthquake data. Maple can also generate code as well. So one common use case is that our users employ Maple to derive symbolic equations. They model systems for first principles physics. They might end up with very large equations that they now need to convert to C, Fortran, Java, Visual Basic for inclusion in another system. Doing that by hand is very time-consuming and onerous, but using the code generation package, you can convert that code into C, Java, Fortran, Visual Basic, and you can optimize the code as well, so it's very numerically efficient. We've enhanced the connectivity options in Maple. Now, some of you may be familiar with MapleFlow. MapleFlow is a product that we launched a few years ago. It's a calculation tool that's aimed at our engineering users. What you're looking at is a Maple workbook that has a MapleFlow worksheet attached to it. It's this worksheet here. I can now run MapleFlow worksheets from within Maple using an enhanced version of the document tool's run worksheet command. So here, I'm going to run the MapleFlow worksheet I have attached to this workbook. I'm going to send in some parameters and extract some results. So as soon as I press enter, Maple runs this MapleFlow worksheet and extracts the appropriate results. This is a fairly lengthy calculation, so bear with me. So there are the results. If I change one of the parameter values that I send in, let's make this diameter larger, press enter. The results that are returned will change. Now, this is really very useful for a number of reasons. For example, now you can do parameter studies of MapleFlow worksheets from within Maple. You can essentially treat a MapleFlow worksheet as a black box that you can send parameters into and extract results from. So here I'm going to send in a vector of diameters. This could be diameters that I've entered into a vector manually or data that I've imported from an Excel spreadsheet. But the key point is that I can programmatically execute a MapleFlow worksheet and perform parameter studies and explore the solution space for a MapleFlow worksheet from within Maple. That's really exciting. You could also create interactive MapleFlow applications as well. So within Maple, you can insert sliders, dials, gauges, and widgets. You can program their interactivity using the Maple programming language. And now you can build an interactive application in Maple that runs a MapleFlow worksheet. That's great if you want to deploy a MapleFlow worksheet to a broader audience. We've also refined the code generation functionality in Maple 2025 as well. You can now generate code from Maple programs that you've written in code edit regions. I really like using code edit regions for writing Maple procedures and Maple code. They have features like syntax highlighting, automatic indentation, bracket matching, command completion, argument completion, and much more. I find code edit regions a much smoother experience for writing Maple code than I do the actual Maple input prompts. But now you can write your procedure in a Maple code edit region and use the code generation function to convert whatever you've written in that code edit region to code. So here I'm converting this code to Python. I could also convert it to a number of other target languages like C, Java, Fortran, Visual Basic, and much more. So one person asks, will we be able to run a Maple worksheet in MapleFlow? I think you can already do that using the document tools worksheet command. That should enable you to run a Maple worksheet from the actual MapleFlow canvas. I think that is functionality that is already present in existing versions of MapleFlow. But if you need an example, please do let us know. Let's move on. Let's talk about visualization. So Maple has a really, really impressive plotting engine. You can generate many different types of plots, and we're gradually refining the plotting engine as well. So a few versions ago, we introduced color bars for contour plots, 3D plots, and other types of plots where a color bar is important. Here's a 3D plot as well. You could generate a color bar for this. We also have specialized engineering plots as well. So here's a psychometric chart. Here's a ternary plot that was generated programmatically, and it gives me the precise color of gold, silver, copper alloys. And if I hover over one of these points, I get the composition of that alloy as well. There are many options for fine-tuning and refining the look and feel of a plot as well. So here I just have a simple demonstration. Here's the default look and feel for a Maple plot. But just by changing some parameters, either in the context panel or on the command line, you can make your plot look very different. So in Maple 2025, we have a new sparse option for matrix plots. That's really useful if you're dealing with sparse matrices. And we've also introduced custom ranges for contour plots as well. So in a plot like this, you can label each axis with a custom range. Let's talk about the core math improvements. So this is the part of Maple that keeps people coming back year after year. Maplesoft are known for the power and the strength of the Maple math engine. It's something that we've built our reputation on, and we're determined to stay in the lead by continuously refining what we offer. We've made many different improvements to Maple's plotting engine, and I'm not going to cover everything, just those improvements that spoke most lively to me. A very common function is simplify. So we refined simplify so that it now recognizes when exponentials can be more compactly represented. Simplification is now more careful to give compact answers by avoiding unnecessary expansions and normalizations. So this result in older versions of Maple would have been more verbose. It's now more succinctly presented. We also have a new vector form of fsolve. You can give fsolve a vector of equations, a vector of initial values. It will then return the results. It won't return a vector of equations. It'll just return the numerical results. And now those can be directly assigned to names, as I've shown you here. There are new features for identifying sequences from its first few terms. So here I have a sequence. I'm sure many of you recognize what it is, but now I can get Maple to give me a closed form expression for the nth term of this sequence. There's a new package called Expression Tools, which will help you visually identify where large expressions differ. There's also new tools for numerically inverting Laplace transforms. Now, many applications in engineering and science result in Laplace transforms, which have no closed form analytical inverse that can be expressed in terms of elementary functions. With a refinement to this function, you can now invert the Laplace transform numerically. So this Laplace transform actually results from an analysis of voltages on a transmission line. It doesn't have a closed form inverse, but it can now be inverted numerically. So let's talk about AI. This is really interesting. I think many people have started working with the various AI tools and services available online. It's an inevitable part of the way many people are going to live and work now and in the future. And a question we've been asking ourselves internally at Maplesoft for some time is, how can we best make use of the current advancements in AI? We started dabbling with that over the last few releases. So we have an AI formula assistant. So on the left-hand side, there's a tab, and these are just examples of items that you can interrogate this AI formula assistant tab for. The concept is that you type in a query which describes a formula that you want. So, for example, let's say the best glide range of a light aircraft. You then click on search. Maple then talks to an external AI service and identifies the most appropriate equation that can be inserted. So if you're an engineering user, you could ask it to identify the deflection of a cantilever with a point load, the volume of a pressure vessel, or a correlation for the psychometric properties of humid air. So here it returned a glide equation. There are various formula that I can insert, but if I can then click on this thing to insert that formula into my worksheet and start working with it straight away. We also have a deep learning package for training neural nets with data. Now, this is something I've experimented with. So, for example, this is an extract from a worksheet I published at the Maple Application Center a few releases ago. So I trained the deep learning package to identify the number of handwritten numerical digits. So you give it some training images. You then ask the deep learning package to train the neural net. You end up with weights associated with each digit. And then you can test the neural network that you've trained with test images. And sometimes it gets it right, sometimes it gets it wrong. However, let's look at what we have in store for you for Maple 2025. And this is really, really exciting. You can now, this is available as a technology preview. You can now generate worksheet content based upon a prompt that you give an AI. We're labeling this as a technology preview. It's still something that's rough around the edges, but we wanted to put this early stage technology preview in your hands just so you can start experimenting with. So, for example, you can ask Maple, how do I derive the formula for an area of a circle? You can give the AI various roles, so a teacher, a scientist, or an engineer. You can then click on a button, and then Maple will communicate an AI and automatically generate some content. So here, this content has been returned and inserted into your Maple worksheet. You can then copy and paste this into your own worksheets and more. Here's another example. So if you're an engineer, a structural engineer, you might want to ask Maple, how do I calculate the compressive strength of slow hardened concrete as a function of time? And there's a request here to use a specific model. I want the AI to assume the role of an engineer. As soon as I click on a button, Maple talks to an AI and returns this content. So this is actually executable Maple code that's returned. This code can be executed and copied into your own worksheets. Now, we're going to return to AI later, but I do want to stress that this is a technology preview. We wanted to dip our toes into the water with automatically generated worksheet content. I think we've done well so far. But as the AI models grow more robust, more refined in the coming years, the content that's going to be returned is going to be content that you can rely on. I wouldn't necessarily say that's the case at the moment, So any AI generated content has to be taken with a pinch of salt and some detached analysis. But as these AI models grow more robust and better over time, this is actually functionality that you can use in your work and analysis. Let's talk about education. Now, I went to university in the late 1990s, and my lecturers were very old school, although our mathematics department did have licenses of Maple, we weren't allowed to touch them. So I only started using Maple in depth when I first started working for Maplesoft. Now, I really wish I'd had Maple when I was studying math. It would have helped me get better grades and learn more mathematical concepts. So we've had the ability in Maple to provide step-by-step solutions for common math problems for a number of releases. We've now refined that content, that functionality, so that the steps are more succinct and more intelligent. So, for example, we have better heuristics for a number of different integration and differentiation methods. So these integration steps are more compact than in prior releases. You can now automatically generate unlimited variants of the same problem for students to solve with the try another feature. That's been added to Maple's Check My Work tools, and that's another feature I really wish I could have had. It's available for many common math principles, including factorization, simplification, integration, and much more. So if I issued this command, Maple introduces these items on my worksheet, a problem for me to solve. I can insert my answer into this text box. I can get Maple to check my work. But if I want to try another variant of the same problem, if I click on this button, another variant of the same problem is generated. Now, there are other refinements and improvements we've made to our offering for educators, and you'll learn more about them in the coming days and weeks as we release Maple. So let's round things off by talking about graph theory. So this is a part of Maple that I've experimented with on a number of occasions. It's something I find really, really interesting. Maple has many different tools for exploring in concepts in graph theory. Graph theory can be used to analyze social networks, electrical circuits, road networks, and much more. So here, for example, is some interaction data for our online discussion forum, Maple Primes. It's taken over a 1 year range from 2018 to 2019, and it just lists the interactions between users. So I can ask Maple to generate a graph of all of this interaction data. And here the argument completion menu has suggested a couple of items I can insert. So as soon as I click on execute this command, Maple generates my interaction diagram. And there are various options for fine-tuning the look and feel of this graph. So for example, I can insert various style options and layout formats. Let's move on. And this is another styling for the same graph. I can also use other functionality in the graph theory package to identify the most influential users on Maple primes for that specific time period as well. So we've made a number of improvements to the graph theory package. There's a new all simple paths command, which returns an iterator, which gives you all the paths from one vertex to another. There's a new tool for identifying all of the ancestors and descendants of a node in a graph. The graph theory package contains a number of special graphs as well, which we're gradually adding to release after release. So here we've introduced 2 new special graphs to the graph theory package. And these are all of the existing graphs, special graphs in the graph theory package. And just to return to AI and AI generated documents, this perhaps is another workflow for AI in Maple, and this is interesting. So here, in this prompt, I'm asking the AI to generate a directed graph for an electric circuit with a number of components and feedback loops. And I'm also asking the AI to give the graph ML and generate a circuit diagram for the circuit as well. And this is the content that's returned. This is the graph ML that the AI returned. This is the circuit diagram, a rather simplistic ASCII representation. There's a description of the functionality of the circuit, but now what's really interesting is that I can take the graph ML that's returned and generate a graph based upon that graph ML. I can then use the various tools in the graph theory package to analyze and experiment the graph. I think that's another use case for AI generated content in Maple that speaks volumes for the future potential of what we should be able to do in Maple with the use of AI. So I think that brings me to the end of this presentation.